Hey everyone, let's go ahead and get started with the next section in our training, which is categorical variables. So what this means is we're going to be looking at variables that usually aren't numerical, but rather represent a category. So in this case, we're going to be using the fish CSV again, but this time we're not going to drop the species column and we're going to go off of that. So let's go ahead and get started. So first thing is, once again, we're going to have to call our, fish data set. And so, but let's call it something different than fish this time, since we're going to be looking at species. Let's call it species DF, right? And so that equals pd.read underscore CSV. And remember, you have to copy the file path or the GitHub link to be able to read that in. And then we're going to go ahead and then we're going to look at species underscore df dot head 5, just to give us an idea about the first 5 columns of that data set. So here we can see, once again, we have our weight, length 1, length 2, length 3, our height and our width. And now we have this new column, species. The first 5 of these just happen to be bream, but we can go ahead and look at what all species there are and how many of each species there are. So I think a great way to do that is looking at a bar chart. So let's go ahead and create one. So we put species DF, and then we want to look at the species column. And then what we're going to do is we're going to want to look at the counts. So how many of each fish are there in that species in this data set? So you call the value counts function, and then we plot, and then we want to look at a bar chart. So we'll just put bar, and then make sure that you close your parentheses, and let's hit Shift Enter. All right, so we can give this chart a title and labels if you want. It's great practice if you want to try on your own. But just for the sake of it, we can see that there's by far the most perch fish in this data set, followed by bream, roach, pike, smelt, parkey, and a whitefish. So it just gives you an idea of the distribution of fish in this data set. So how can we actually convert this into a format that is usable for our AI models? So we can't just leave the words perch and everything else in there, because strings can be kind of confusing. So what we're actually going to do is replace each of these categories with a number. So how we're going to do that is we're going to take our species DF again, and we're going to look at the species column. Remember that spelling and typecase matters. And then we're going to look at the species DF. And then what we're going to do is a dot replace function on the species column. So species again. And then we do dot replace. And since we're going to be replacing a lot of values, we're going to want to use a parentheses. So we're going to replace bream as 0. Make sure you use the quotations bream as 0 because we want it to be a number and not a string. And then we're going to do parkey. Once again, remember your quotations. We're going to do parkey as number 1. Remember, we always want to start our numbers from 0, so that's why we're starting with 0. And then we'll go to our perch, and that's going to be 2. And then we're going to go to our pike. That's 3. And then we've got our roach, and roach will be 4. And then we've got our smelt, which will be 5. And then last but not least, the white fish, which will be 6. And so then we're going to go ahead and close those parentheses out. And then make sure you get your parenthesis in there. And then we're going to hit enter. And then we want to go ahead and see the new species underscore DF dot head 5. So when we run that, we can see now that all in the species column, we see all zeros, which is bream, right? So if we go back and scroll back to above, here it was bream, and now we've replaced that with a numerical category, which will be 0. So now let's get into the typical AI ML workflow, which obviously means we have to work on our XY training splits. So we're going to take X, which will be species underscore df dot drop. And then we're going to drop the species column because we just want all the other variables. This equals 1. And then we're going to do Y, which will be species underscore df. And then that will be just the species column because that is what we are trying to predict. Now that we've defined our Y and species, what we're going to do is our train test split. So we're going to do X train, X test, Y train, Y test, and that equals our train test split. And then this time we're going to look at our X, our Y. We add in a new parameter this time called stratify. So this just labels what column is going to be our categorical column. So it's going to be our Y. And then we explain our test size to be 0.2 because we want to train on 80% of our data. And then random state, let's go with 72. Close our parentheses and run that column. Great. So now that we've run that, it's time to go ahead and instantiate our model. So this time we're going to be still using a method in the XGBoost library, but we're going to be using something called XGB classifier. So this is what is used for categorical problems versus the previous XG regressors used for linear regression problems. So we go ahead and call it the same way. We call it XGB classifier is the name of the model. And then we want to use the evaluation metric of RMSLE. So that is root mean squared logarithmic error. So that just looks to minimize the differences in the values between the predicted and the actual values. So we go ahead and we instantiate that model. And then now the next thing we're going to do is we're going to perform the parameter search again. So you can go ahead and copy it from above. But this time, what we're going to do is there's actually we're going to copy it from above just because I don't want to have to type it out again. So what we're actually going to do here is we're going to, wrong thing. So let's copy this parameter grid and then paste it down here, right? But we're actually going to take this booster out because that was looking at parameters in the XGB regressor model, and that's not what we're looking at this time. So remove that, and remember verbosity is how many messages or warnings that we get while this parameter grid search is running, and sometimes that can be a lot, so we just don't want to see it, hence we set it to 0. So this time for our parameters, we'll look at max depth and estimators and learning rate. I explained what those are in the previous video. So if you have questions about that, I would go ahead and watch that or check out the link at the bottom, which will explain it more in depth. But moving on, so now that we have our parameter grid set up, let's go ahead and set up our search. So we kind of do the same thing. We set up a search grid. So we do a grid search with cross-validation. And that's a topic we'll get into in future trainings. And so we do a cross-validation and we go ahead and we input our model name, so XGCLF, and then we look at the param grid, and then we want to cross-validate 5 times. And then we go ahead and fit all of that onto our X train and Y train data. And then we want to go ahead, that's fine. While that's run, we want to go ahead and see what the best parameters are. So we'll go ahead and do a print statement while that's running. The best hyperparameter are, and then we want to look at the best hyperparameters for each of those things from search. So we do search.best underscore params, and then we close that out. So once this is finished running, we can go ahead and run this. As I said, things like grid searches can take a lot of time even on Jetstream, just because it's a very long exhaustive search that the computer is running. So just wait for your code to run, and then we can go ahead and run the next piece of code. All right, so it looks like it ran. So we'll go ahead and run this column so we can see what the best parameters are. So here we see that the best parameters are a learning rate of 0.01, a max up to 4, and estimators of 400, and verbosity of 0, which is what we had put in there ourselves. So this is great. And so now that we have our parameters, let's go ahead and input these parameters into our model. So we do xg underscore CLF, which is the name that we gave it. XGB, we call the XGB classifier model again. And then we go ahead and input our parameters. So learning rate, we want to do search dot best params, and then we want the best params for the learning rate. Right. So remember, that's one way to do it. And the other way to do it is to actually hard code it in. So we can look at n estimators as equaling 400. And then we can change it up again to do max depth equals 4. And then once again, the evaluation metric we're going to be looking at that we want this model to minimize is we want to minimize the difference in RMSLE. And so we take all of that and we go ahead and then we fit that model onto our training data. So then we look at X train and Y train, and we go ahead and run that column. And there we go. We can see that the model that it spit out with all the parameters that we inputted, and now we can actually go ahead and predict using these models. So let's go ahead and do that. So let's do predictions again. And we want to predict, we want to use the XGCLF model that we just created to predict values from our X test data. Perfect. And so why don't we try to go ahead and compare the two? So we're going to create a compare underscore df. And so what we're going to do here is create a data frame that has the actual values, and we're going to get those values from Y test. And then we want a column called predicted, and then we want to call that from the predictions that we just created. And then we go ahead and close that. And then let's go ahead and print that data frame out. Print compare df. All right. When we run this, that we can see that for the first one, the actual is 4, predicted is 2. So we got that one wrong, but then we happen to get the next few right. And so there are a few outliers in here where the model mispredicts things, which is to be expected. But let's go ahead and dig into that a little deeper by looking at some of the accuracy scores, such as our RSMLE score, our R2 score, to get a better idea of how accurate our model is. So we're going to look at the RSMLE, and then we're going to do the square root of the mean squared log error of our Y test data and our predictions. Close that out. And then, all right, so let's go ahead and print that now. So we do print the score, or let's do the RMSLE is, and then we want to look at 5 decimal places like we did the last time. And then we look at SLE, and we go ahead and put my parentheses in the wrong place, but we go ahead and run that. So we see that our RMSLE here is about 31 or 0.31, which when you're thinking about most of these measurements, again, being between the range of 10 to 30, not too bad. And then we can do the same thing looking at the R2 score, right? So we look at our R2 score, we look at it for XG underscore CLF model, and then we want the score, and we want it for our test data. We want it X test, Y test. And then we're going to go ahead and print the score. So we print R2 score times 100 because we want it in a percentage. And then we add a percent sign, close that and print. So our model is about 71% accurate. Not the greatest, but also not bad. As I said, industry standards around 70%. This is also a great example to show that as your models get more complicated, as you have more rows, more variables, categorical variables that you're looking at, the harder and harder it is to achieve a high level of accuracy on these models. It becomes more complex. So that's really where you get in the field of machine learning and AI, is everyone is trying to improve the accuracy of these models. So for instance, even ChatGPT has a accuracy rate around 70 to 75%. And that's considered a really great model. So when you think about the amount of data and the amount of variables that it's having to deal with and predict. So just, just a great example of how this is going to work in the real world. And so there is another thing that I want us to get into. And so that is going to be a confusion matrix. So what is a confusion matrix? It basically shows where there are the most false positives, positives that come up as false. So it's how many times one species is confused for another and how accurate our predictions are. So let's go ahead and create a confusion matrix. So we'll call it CM confusion matrix. And this is once again part of the sklearn family and a great visual tool for you to identify and see how well your models are working. So we call our excess values and we want to look at our predictions. And then we're going to use Seaborn to create the heat map so that there's colors to it. And then we're in CM. I want to annotate, which just means it has labels and everything else we need true. And then this is another just kind of visual parameter. And then we go ahead and let's label things this time. So we'll do plot, we will do our X label, to be predicted species. All right. And then we'll do our plot Y label to be our actual species. So this would be our Y test data, actual species. And then let's go ahead and give it a title, plt.title, and then let's call it XGB species classification. Great. And then let's go ahead and plot.show. All right, now here we have our confusion matrix. So starting in this corner, when you have something that is 0, 0, 0, 1, this basically shows true positives. There were a lot of great, the model was really great at predicting species 0, which I think was bream at being bream. When it gets down to 1, 1, it's a little more difficult. Species 2's the model is predicting great. And so those are looking at your true positives, right? Some of these ones where it's you see an actual species is 6, but it was marked a 2. Well, those are your false negatives, right? So that means they were not the correct answer, not marked properly. And then you see here that the actual species was 2, but then again, it was marked a 5. So these are other areas where the model did not do as great a job of being able to correlate those things. So that's what a confusion matrix is great for, to see the number of true positives and false negatives, how accurate the model is at predicting certain things, which is really great. And now I want to just give you kind of a real world example of how you might be using this. So I have this code that was already written in, and we're just going to run it. And so what this does is say you went out in the wild and you're doing fish research and you happen to catch a fish that you need to figure out the species and visually that you can't. So you can come in here and you say the weight is about 250. It's about 54 centimeters for length one, 53 for two. Let's go 27 here, height of 11, and a width of 5. And we can use this model to create an interface where you can predict the species. So based on the lengths of this fish and all of its dimensions, I would say with about 72% accuracy that this fish is a parkie. So I think it's just a great way to visually explain how models like this might be used, and you can create interfaces like this through Python as well. So that is it for the Jetstream AI basics. You should have been able to cover how to create a linear model using single variables, multivariables, as well as using classification algorithms, and then you would have gotten a great understanding of all the visual ways we can show information from scatter plots, confusion matrix, correlation matrix, different ways to explore and understand the data. Thank you so much for following along with our training as well as being involved in our Jetstream program. Thank you so much.